Hey everybody, we're back with our second part of integration by parts. This is where we're going to find a definite integral using integration by parts. Typically, there's two approaches that we can take. The first one is to find the related indefinite integral using integration by parts, and then just use the fundamental theorem of calculus once we get the whole antiderivative. The second way is to find the definite integral directly by using the limits of integration at each step. In other words, when you do the uv minus the integral of v du, you're going to evaluate the u times v at b and a and subtract, and then subtract from that whatever you get for the definite integral from the v du. Example 7 here, definite integral from 0 to pi over 4 of x secant squared x dx. We'll try method 2 to start off with. So here, u is going to be equal to x, and dv is equal to secant squared x dx. Remember, we're using Lipit for figuring out how to identify u. There is no log, there is no inverse trig, and x is understood to be a polynomial function. So du is just dx, and v is equal to tangent x. Remember, the antiderivative of secant is tangent. So this is going to be uv, so x tangent x, evaluated from 0 to pi over 4, minus the definite integral from 0 to pi over 4 of tangent x dx. Then you would have x tangent x from 0 to pi over 4 minus the antiderivative of tangent, if you remember, is natural log absolute value of secant, and we'll evaluate that from 0 to pi over 4. It's important to keep your work very organized here because it can get a little bit confusing. So when I plug in pi over 4, I have pi over 4 times tangent of pi over 4, which is 1, minus 0 times tangent of 0, which is just 0, minus natural log evaluated at, or natural log of secant evaluated at pi over 4 and 0. Secant of pi over 4 is root 2, so this would be natural log of root 2, minus secant of 0 is 1, and natural log of 1 is 0. We would subtract those. Then you would have pi over 4 minus natural log of square root 2. There you go. Now, another example is finding the area under the graph. If we want to find the area under the graph of x natural log x from 1 to 2, we could set that up using a definite integral. So the area is equal to the definite integral from 1 to 2 of x natural log x. Since we have a product in the integrand, one of the techniques we have is integration by parts. Of course, that's the section we're on. But also, don't forget about u substitution or inverse trig functions or the log rule or anything like that. Those still apply, but this is going to be integration by parts. So if we use Lipit, we have LIPET. We do have a log, so u is going to be natural log x, and dv is going to be x dx. So du is 1 over x dx, and v is 1/2 x squared. So uv is going to be 1/2 x squared natural log x minus the integral of 1/2 x squared times the 1 over x, which is just going to be x dx. So you would have 1/2 x squared natural log x minus 1/4 x squared. And then with this, we can plug in 2 and 1 and subtract. So I'm using method 1 here. So if I plug in 2, I would have 1/2 of 2 squared times natural log 2. So that'd be 1/2 of 4. So 2 natural log 2 minus 1/4 of 2 squared, which is 1. So that's the function evaluated with b equals 2, and then minus the function evaluated at 1. Natural log of 1 is going to be 0, minus 1/4 of 1 squared is 1/4. So we would have 2 natural log 2 minus 1 plus 1/4. And 2 natural log 2 we could write as natural log 2 squared, or natural log of 4 minus 3/4. All right, guys, that's it for this one. Hope that was helpful to you. Take care.